All right, here we go with lesson 3. Just going to jump right into it. Yesterday, we learned 2 shortcuts to prove triangles are congruent. Hopefully you remember this. Side, 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 and side angle side. Today, we're going to learn 2 more. I told you that at the end of the lesson that we were going to do that. So what's the first one for today? ASA. Probably guess what that stands for. It's written there if you didn't guess it. Angle, side angle. If 2 angles and the included side, here we go again with the included idea. But this time it's the 2 angles and the included side. Yesterday it was the 2 sides and the included angle. But if you have 2 angles and the included side of a triangle are congruent to 2 angles and the included side of another triangle, then the 2 triangles are congruent. So for this example, to show you what's going on, I have 3 triangles there. Name the 2 that are congruent by ASA. Well, you're looking for the ones that have the same markings. And I want you to notice the difference. It's, by the way, it's these 2. Okay. Notice where this marked side is. It's outside the 2 angles. So if I look at these 2 angles, 1, 2, the included side is the side that I would use to draw between those 2 angles that are marked. So the included side would be the angle or the little line that I just drew. All right, so it's not this one. So it's those 2. The congruent statement here would be triangle CAT is congruent to triangle C matches up with G, A matches up with D, and T matches up with O. Okay, so that's angle, side, angle. Angle, angle, side, on the other hand, is if 2 angles and the non-included side are congruent to 2 angles and the non-included side, or a non-included side, because there's actually 2 non-included sides. Then the triangles are congruent. How many included sides do 2 angles have? So if I have 2 angles how many included sides are there? 1. So how many non-included sides do 2 angles have? There's 2. Okay. So we've got a picture here. How do we know that angle PQT, that's this angle, is congruent to angle SQR? That's this angle. Should be used to that one by now. I've seen that one a lot. That's vertical angles theorem. Which sides would need to be congruent to have ASA congruence? So notice when you write ASA, where's the S at? It's between the 2 A's. Well, which 2 sides are included in these 2 triangles? Well, again, look at the 2 angles that are marked. So in the one on the left, it's P and Q. Draw the line between P and Q. That's the included side. So PQ would have to be congruent to, and do the same thing on the other triangle, draw a line between the 2 angles that are marked. So that would be SQ. Which sides would need to be congruent to have angle, angle, side congruence? Well, either of the other 2 sides. So PT, if I had PT congruent to SR, it would work. Or if I had QT matching up with QR. Okay. Now, there is a letter combination. Basically, if you have 3 angles or 3 parts, angles and sides, a lot of times it's going to be enough to prove 2 triangles are congruent. But there is a letter combination that does not work. And that letter combination, a lot of people get a kick out of this, is, yes, a swear word that you would get in trouble for saying in school. So if you write that on your test and you're not trying to be funny, you should look at that and say, "Ooh, can't do that." Now, a lot of people get confused and they think that that is okay, side, side angle. Well, that is just the bad word backwards. Right? So you can't have the bad word forward or backward. not a way of proving two triangles are congruent. On the back, we've just got a bunch of proofs, not a bunch, 3 of them. Okay. So again, I'm going to type instead of writing it with my finger. This is almost the exact same, it actually is the exact same picture we had on the previous problem, but a little bit different given information here. All right. So in the picture, the given is the same, but I also have a piece of given information that's in words as well. I'll just start with the words one. Q is midpoint of PS. And yes, you can abbreviate, that's fine. How do I know? Well, that's given. Well, what does that mean? If I have something that's not saying something is congruent to something else, I want to use it. So Q is the midpoint of PS. So PS, you see PS there, which means that these two, it gets split in half. So I'm going to mark those on the picture. Good idea to start doing that. Mark things on the picture. What can I say then? PQ is congruent to SQ. Why? That's the definition of midpoint. And there we go. I've got one piece. More. Well, angle P is congruent to angle S. How do I know? It's also given in the picture this time by the markings. So there's 2. I'm going to add those little congruent things in there. What's the third one? Well, we talked about it already on the front. We have vertical angles here, don't we? So I could say angle PQT is congruent to angle SQR by the vertical angles theorem. Go ahead and mark that. One, it's the third piece. That's good. That's what we wanted. And I'm going to mark it on the picture. Now I have 3 parts. Are the 3 parts a good letter combination? Yes, they are. So now I can say triangle P, and I'm going to use exactly what's written down here. I'm going to copy that because that's what I want it to match exactly. Now, would you get it wrong if you put triangle PQT equals SQR? No, you wouldn't. You'd be fine. But I just want to make sure that I am matching and doing exactly what I said I was going to do, which is prove that those 2 triangles are congruent. How do I know that they're congruent? It's one of those shortcuts. Which one? Is it angle, angle, side, or angle, side, angle? Well, the side that's marked is between the 2 angles that are marked, so it's angle, side, angle. Okay, and that is a proof. All done. Okay, let's move down to the next one. By the way, you're going to notice I have some difficulty level things here. 10 is the hardest. 1 is the easiest. This one wasn't too bad. Pretty easy. You may not think it's easy yet, but what I'm saying by that, when I'm giving a difficulty level, it's once you've done practice on all these proofs, like if this were a test question, it would be a pretty easy proof here. Next one's a little harder, not much, but a little. Okay. Make this so I can type on it just a second. Sorry, I'm making sure that I can type here. All right. Number 1. I've got nothing marked on the picture, but I have 2 pieces of given information down below. So I'm going to say RN bisects angle MNP. That's given. Now, what does that mean? What does bisects mean? Well, it means it cuts the angle in half. Which angle? Angle MNP. So MNP is this angle here. That got cut in half. So that means that these 2 angles are congruent. So the meaning of bisect is what I'm going to use. So that's going to be my reason to say that angle MNR is congruent to angle PNR. I use the definition of, and technically it's angle bisector, but if you just put definition of bisect, I'd count it. So that's the first one. I got an angle congruent to another angle. All right. Next, well, there's more given information down here, right? Angle M is congruent to angle P. Why or how do I know? It was given to me. I said it in the words. All right, so that's number 2. I'm going to mark it on the picture as well. Angle M is congruent to angle P. I need a third. Now, I could say 3 angles. But that's not one of the theorems we've learned. We have not learned angle, 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 and we never will because it's not a thing. Okay, we need a side. To show 2 triangles are congruent, you have to have at least one side congruent. Well, the only side I can say anything about is NR, and it is congruent to itself. Why is it congruent to itself? Reflexive property. Okay, and that's the third piece. Go ahead and mark it. Okay, congruent to itself. So now I can say the triangles are congruent. I'm going to copy what I'm trying to prove. So triangle MNR is congruent to triangle PNR. Why? Okay, look at it. I have 2 angles and a side. So it's either going to be angle, angle, side, or angle, side, angle. Is the side that's between the 2 angles the one that's marked? Hopefully you see that it is not. This one is angle, angle, side. We're done with this proof. Okay. Clear it out. And let's jump down to the third one. Do this again. Sorry. Start looking at this one. And as you look through it, try to find the 3 pieces. By the way, this is a more difficult one. Difficulty level of 5. So here we go. I didn't give you any words of given, but I gave you 2 things in the picture. I'll start with the easy one. Angle F is congruent to angle H. We'll go ahead and say that's one of the pieces. That's good. 1 done. All right. It's already marked on the picture too, so I don't need to worry about that. Now, this piece of given information, a lot of people are going to put FG is congruent to HJ. You can't do that. FG is parallel to HJ. That's what those little triangles, filled in triangles mean. It does not mean they're congruent. It means they are parallel. Now, we've talked about parallel lines and what they do when they're cut by a transversal back in Unit 3. We're using that idea again. All right, so I've got alternate interior angles here. All right, so this is my transversal. This is my parallel line to this one. I've got alternate interior angles right here. Right? Now I can't say these. Those are not good because we don't know if these 2 lines are parallel or not. We don't know that. Okay, so we can't use those angles. What we can do though is use the angles that I have circled there. Now I got to be very careful in how I name those. I can't say angle G and it is congruent to angle J. That doesn't make any sense. Angle FGJ is congruent to angle HJG. Why? Well, I have parallel lines and I'm concluding that the angles are congruent. That is alternate interior angles theorem. You got to have the word theorem at the end because, yeah, we've talked about that before. All right, so that's the second piece. And I'm going to go over here to the picture. I'm going to get rid of all that other stuff. And I'm going to mark that. That is congruent to that. I need a side now. What side am I going to use? Hopefully you see that I've got a side that's in both. GJ is congruent to, now be careful here. I sometimes am a stickler on this. I haven't decided yet whether I'm going to be. You could just say GJ is congruent to GJ, but technically you don't want to do that. If you look down here at what you're trying to prove, look how GJ matches up with the other side. GJ does not match up with GJ. It matches up with JG. It flips it. Does it always do that? No, it does it here because the triangle's kind of flipped. The two triangles are kind of flipped. But there's my third piece. Now, the fact that they're flipped doesn't really change anything as far as why they are congruent. It's still the reflexive property. Okay, and that is the third piece. We'll go ahead and mark it. So now I can say triangle FGJ is congruent to triangle HJG. Why? Take a second to look at it. Okay, we've got two angles and a side. Is the side that's marked between the two angles that are marked? Now we're looking at one triangle here. Those are the two angles marked. Is the side between those? No, it's not. So this one is angle, angle, side. Okay, and that does it for this video. We got one more shortcut to do.